Now students, in a projectile motion some important parameters: maximum height, time of flight and horizontal range. Sometimes 3 marks question, the question may be arranged: derive an expression for maximum height. Derive an expression for maximum height in projectile motion. So already you know the definition of projectile motion. When a body is projected with certain angle theta to the horizontal is called a projectile. The path described by the projectile is called a trajectory. And also you know the example: a football player kick the ball. Example for trajectory. The ball move, the path, the shape is a trajectory. So theta is an angle of projection. The maximum vertical distance, students, now we observe the maximum vertical distance traveled by the body. The maximum vertical distance traveled by the body after vertical component velocity. Vertical component of velocity v equal to 0. The body come back to ground. This point to here, maximum point to earth, that is the maximum height. So what is the maximum height here? The maximum vertical distance traveled by the body. So after velocity v equal to 0, that height, that above point to earth surface, you are measuring maximum height. So now the maximum vertical distance traveled by the body is called a maximum height. Now in a diagram, so now you observe the body rise from 0 to maxima here. So after vertical component of velocity v equal to 0, so h is the maximum height. So how to prove the equation maximum height in a projectile motion? So in a motion in a straight line, so already you know that, so motion under the acceleration due to gravity. A body thrown up, it moves upward against the gravity, so g value taken to be negative. The equation of motion under the gravity, upward motion, so v square equal to u square minus 2gh. The equation of motion under the gravity, when a body move upward against the gravity, the equation is taken as v square equal to u square minus 2gh. V is a velocity, a vertical component of velocity. U is a, so velocity of projection u along y-axis u sin theta. G is the acceleration due to gravity. H is a maximum height. So now V is a vertical component of velocity, what? 0. So take mention 0. U, velocity of projection, it can be resolved horizontal and vertical. So the maximum height we measured which direction? Vertical direction. In the vertical component, what? U sin theta. U equal to u sin theta. So u square sin square theta minus u equal to u sin theta. Now squaring, u square sin square theta minus 2gh. So here vertical component, so v equal to 0, u square sin square theta minus 2gh. So this above equation as example of mathematics, x minus y equal to 0. What happened? X equal to y. So here also u square sin theta minus 2gh equal to 0. The above equation as u square sin square theta equals 2gh. Now h equal to maximum height. H equal to what? U square sin square theta by what? So 2g. Now how to calculate the maximum height formula? So this is the capital H. This is very important mathematical formula. In a projectile motion, how to calculate the maximum height to reach the object or ball. Now using this formula, h equal to u square sin square theta by 2g. U, the body may be projected. How much velocity? Maybe 20 meter per second or 30 meter per second. The given u value mentioned here. After theta, so how much angle a body is projected, at what angle? Maybe you projected angle maybe 30 degree or 40 degree or 60 degree. So given for theta value, substitute here. So 2g, acceleration due to gravity, so 9.8. So now we have u, theta and g, the three values substituted this equation, then you calculate maximum height. So this is the expression for maximum height. So once I repeat students, the vertical component of velocity v equal to 0, that is the maximum height. The equation of motion under the gravity, upward motion, v square equal to u square minus 2gh, vertical component 0, u square sin square theta minus 2gh. So now you simplify h equal to u square sin square theta by 2g. Now one more 3 marks question here. Derive an expression for time of flight. Now first parameter maximum height, second one time of flight. So what is the time of flight? The time taken by the projectile motion to reach the ground is called time of flight. So now we have 0 to here, time of ascent. Maximum to here, time of descent. Now total time. Total time for ascent and descent. The time taken by the projectile motion to reach the ground. In ball or stone thrown up, the time taken throw to the ball reach the ground, that is the time of flight. Time taken by the projectile motion to reach the ground is called a time of flight. So how to do the mathematical equation for time of flight? Now second equation of motion. The second equation of motion, so here s equal to ut plus half gt square. S equal to ut plus half gt square, second equation of motion. So now here s equal to ut plus half, at square. S equal to ut plus half at square. The time of flight you calculate. So here, so time taken to reach the body to reach the ground. So here s equal to 0 and u equal to the vertical component what u sin theta. The body is thrown up, it moves against the gravity. So in a place you taken for minus d and small t equal to capital T. So now here s equal to 0, u equal to u sin theta, vertical component, and acceleration small e equal to minus t. The body move upward against the gravity and small t equal to capital T. Now substituting for this equation, s equal to what? S equal to 0. So now u, velocity what? U sin theta. U sin theta. So into what? Capital D. So plus into minus, minus. So 1 by 2. So G, capital D square. So once again u sin theta into t equals half g t square. Now here square and t cancel. So u sin theta equals what? 1 by 2 g capital T. Now cross multiplication here, 2u sin theta equals g into t. So g into t. This equation written as t equal to 2u sin theta by what? So this is the expression for time of flight. This is the expression for a time of flight. The time taken by the projectile to reach the ground is called a time of flight. How to calculate the time of flight? So t equal to 2u sin theta by g. U is a velocity of projection. Theta is a angle of projection. So after g, acceleration due to gravity. So now u theta g are substituted this equation. Substituting. Finally calculate capital T. Capital T is the what? Time of flight. So one more parameter. Derive an expression for horizontal range. So three are very important here, students. Maximum height, time of flight, and horizontal range. So horizontal range. Now in diagram you see this is R. Capital R is the range. What is the horizontal range? The distance between point of projection and the particles meet the plane is called a horizontal range. Example, you are standing on point, throw the ball. The ball it move projectile motion after it meets certain point on the earth's surface. So then you measure your point of projection to particles meet. The distance is called a range. So now O is a point of projection. P is a particles meet the point. So distance from O to P, that is called range. So what is the range? The distance between point of projection and particles or body meet the plane. Horizontal plane is called horizontal range. So how do you know the mathematical formula for horizontal range? Now simple method here. Horizontal range equal to horizontal velocity. So the velocity of projection along the x-axis of horizontal velocity u cos theta into time of flight. So very simple here. Horizontal range equal to horizontal velocity into time of flight. So horizontal range or horizontal distance. So now R, capital R equal to horizontal velocity. So x-axis horizontal velocity what? U cos theta. U cos theta into time of flight. So already you know the time of flight formula. Capital T equal to 2u sin theta by g. Time of flight 2u sin theta divided by small g. So now R equal to so here u into u what? U square into so here 2 first write sin theta, so after write cos theta, so divided by g. Students, the above equation written as here u cos theta into 2u sin theta by g, but here u into u square. So after I mention here 2, first I write sin theta, last mention here cos theta, in denominator small g. In mathematics, trigonometry, 2 sin theta cos theta is very important for here. 2 sin theta cos theta. 2 sin theta cos theta, the standard formula sin 2 theta. Sin 2 theta. Friends, in trigonometry, mathematics in trigonometry lesson, standard mathematical formulas, 2 sin theta cos theta value equals sin 2 theta. So R equal to, so u square sin 2 theta by divided by small g. So this is the expression for horizontal range of a projectile motion. So R equal to u square sin 2 theta by g is very important in our numerical problems. How to calculate the range given for u value, angle, theta projection, g is the acceleration due to gravity. And one more general question, students, here. At what angle to get maximum range? So different angles are there here, maybe 30 degree, 40 degree, 60 degree, 90 degree. 45 degree the projectile motion, you get maximum range. Maximum range. So one more question. At what angle to get maximum range? So the angle of projection theta equals 45 degree. Then ball or body it goes long distance, long range, rather than large or maximum horizontal range. So this is a very important question. This is one more question. At what angle to get maximum range? So answer here, the angle of projection theta equals 45 degree. So now look at the board here students. R equal to u square sin 2 theta by g. So now here what? Theta equals 45. So 2 into 45 what? 90 degree. So R equal to u square sin. So 2 into 45. 2 into 45 what? 90 degree by divided by what? G. Sin 90 degree value what? 1. So then range is maximum. R maximum equals u square by G. So R maximum, range is maximum, u square by G. Sin 90 degree equal to 1. So here angle theta equals 45 degree. Then sin 2 theta, 2 into 45 90. So now here theta equals the angle of projection, theta equals 45. Then you get large range or maximum range.